two convex lenses, each of focal length 10 cm, are placed at a separation of 15 cm with their principal axis coinciding. Alright, so let's draw it. This is my first convex lens, my another convex lens, and the focal length of each of them is 10 cm. They are kept at a separation of 15 cm from each other. Now show that a light beam coming parallel to the principal axis diverges as it comes out from the lens system. So first of all, it is coming parallel to the first lens, so it will be converged at its focus, that it at a distance of 10 cm. I mean, let's say this is my point A, which is at a distance of 10 cm from the first lens. Then all the rays will be converging to this very point. Alright, and it will go like this and it will diverge somewhere like this. I'll prove it. Okay. Now first of all, it is very clear that from the first lens, the first image will be formed at point A, that is at the focus, that is at a distance of 10 cm from the first lens. So the distance from the second lens will be 15 minus 10, that is 5 cm, and of course if I took the sign convention, that will be negative because it is at a distance 5 cm left hand side from the first lens. Focal length is given to me as 10 cm, but obviously I'll use the lens equation to calculate the value of V. So it comes out to be minus 5 is equals to 1 by 10. So V comes out to be 10 cm with a negative sign. Fine. So it clearly shows that value, that is a final image, is forming as at minus 10 cm, that is on the left hand side of itself. So the final image will be virtual, and since it is a virtual, then the rays will be diverging. Alright. In second case, find the location of the virtual image formed by the lens system of an object placed far away. That is what I have calculated in first part. V comes out to be 10 cm from first lens as well as from second lens. Alright. In third part, I have to calculate the net focal length of the equivalents. Fine. So 1 by f net is given as 1 by f1 plus 1 by f2 minus d times of f1 f2. So you just have to substitute the value. The focal length of each lens is 10, distance is 15, and this is again 10 and 10. So the net focal length comes out to be 20 cm. That is the answer. Now one thing to note, that as it is written over here, that the sign of the focal length is positive although the lens system actually diverges a parallel beam incident on it. That is what is happening.